Hey team, this is Philip Moore from Gizmo Data. I'm going to take you today through some TPC-H benchmarking on the GizmoSQL iOS app. So as you may know, GizmoSQL came out for iOS just this past week. I'm excited about that because it's a great way to experiment and learn more about GizmoSQL, which is an Apache Arrow Flight SQL server built with the DuckDB execution engine. So there's another video that we did earlier that kind of demonstrates how the app works and stuff. So I won't get too much into that, but we'll talk more about how to benchmark TPC-H in GizmoSQL. So without further ado, I'll kind of launch the app here. And I've got a database mounted. I call it, it's the same one we demoed in the video last time, demovideo.db. And that's a DuckDB database file that has a 1 gigabyte TPC-H data set in it. So it has the classic line item, orders table, region, nation, parts, and so forth. So it's a little star schema meant to represent like an online store or something. It's a really good benchmarking data set, obviously. It's designed exactly for that purpose. So we've got the app up here. The server is stopped. I'll go ahead and start the server. And just to kind of give you the lay of the land, remember that you have the schema browser here in the app. So you can click on the catalog, which is demo video, the schema, and then you see the tables. So if you want to see line item, there's the columns in there. You can preview the data and so on and so forth. So it has basic query activity as well. But we're going to connect from dbeaver. So I've got dbeaver up here, and I'm going to stretch this window a little bit. Unstretch, I should say. And so I've got a connection set up here. I've got the GizmoSQL JDBC driver downloaded and installed. So if you go to the GitHub repo, there's a link to a setup guide that shows how to install the GizmoSQL JDBC driver, which is basically a variant of the Flight SQL JDBC driver, just with some extra GizmoSQL fixes and tweaks. So anyway, I've got, as you can see here, I've got a JDBC URL here for GizmoSQL, and then it's 192.168.4.38, which happens to match this guy. We're going to use encryption because TLS is enabled even on the iOS version, but we're going to disable certificate verification because the cert is self-signed on the app. So we've got the GizmoSQL user, and we've got the password, which is Joe, which is what we set to connect to our iOS GizmoSQL server. All right, so I'm going to log in here, and now you can see we're successfully connected, and that session's bumped to 2. And we're going to expand our demo video catalog and our main schema and our tables, and you can see the tables that we have, and that should very well match this list right here. All right, so we are connected, and if, let me close all these, and we'll open a SQL script here. And we will execute this query, select star from line item, and that ran on the phone. And if you go to the logs of the phone, you should very well see that. So if we scroll down to the bottom, we can see the last query that ran here was select star from line item. And if we run it again, we should see the logs move, and boom. So you're actually connected live to this phone. And if you want to get an idea of how much data is in here, you can get a select count star, and there's 6 million rows in this line item table. So it's not a trivial amount of data. It's actually a lot of data. But the cool thing about this is that you can see with GizmoSQL, your iPhone is actually, it's a database server, and it's really fast actually, because iPhones have 6 cores. Like this is a modern iPhone 16 Pro Max. It has 6 cores and several gigabytes of memory, and 256 gigabytes of storage. So you can fit a lot of data on here. Not that you want to fill up your iPhone with a DuckDB database, but you could if you wanted to. So if you scroll up here to the top, you can see that some stats about it. Basically, the CPU has 6 cores, 7.4 gigabytes of memory, and so on and so forth. So we're using Apache Arrow 2301 and DuckDB 152. All right, so let's go back to the server here. And, we've got basic connectivity, but now we want to kind of benchmark and run some TPC-H benchmarks. So there is a PyPI package that we've created at Gizmo Data called Benchmark Flight SQL. And it's a package that lets you basically connect to a GizmoSQL instance and run some benchmarks quite easily. So in the package, there's a TPC-H YAML file with all the 22 TPC-H queries. And so what the package does is it loops through those queries and just runs them all several times, so you can get an idea of the performance of the GizmoSQL package, GizmoSQL server rather. Sorry. So in the README, we talk about how to run this thing, but basically you set up an env file that says how to connect to the server. And so we're going to connect to 192.168.4.38, 31337, disable certificate verification. We're connecting as GizmoSQL user, and the password is Joe. Right. So going back to our README, it's pretty easy to run this. The default args will run TPC-H queries 3 times each. And we can just go ahead and paste that in here because this package is already installed. I pip installed it. And let's see what happens. And so it's going to run all 22 queries. You can see the session count bumped up. And so that took a good 5.7 seconds. And it actually ran each of the 22 queries 3 times. So it's actually really good performance, just a little bit over a second per run. So if I go to the logs here, and I run that again, you should see those logs kind of go rather quickly. And so the server is actually kind of going nuts, right? It's got this session that's running these 22 queries 3 times each. So we actually ran 66 queries there against that 1 gigabyte data set, doing joins, aggregations, filtering, all the good stuff that TPC-H does. And you get that great performance from the DuckDB 152 engine. And this phone is actually, like, it rivals the database server just from a few years ago. So it's actually really incredible, the performance that you can get. All right, so we've ran with one session here, and we ran these queries 3 times each. There's a cool way to kind of get the stats of those runs. Let me, bear with me here. So there's this little utility in the package to convert the JSON output of the tool to Excel. And if we open up that file that is generated by this conversion command, so that brings up this Excel sheet here, and you can see if you look at these rows, like the row count output was 4, this one output 5 rows, this one output 2 rows. It ran each of the queries 3 times. It's a little bit hard to see there. All of them succeeded 3 times. None of them failed at once, so they all succeeded. And if you expand the mean runtime, you can sum that up to get a total of the runtime of the entire benchmark. Oops, sorry. Let me see if I say sum and select these, hit enter, and you can see that on average, when you calculate the total for one run of each of the 22 queries, it's around a little over just 2 seconds. So actually pretty good performance of the benchmark. All right, so we kind of proved that, hey, you can run TPC-H, but we didn't run it. We didn't try to beat the crap out of our phone here, but we actually want to do that. So let me pull up the phone again. And we're going to, oops, bear with me here. All right, so we don't have any sessions here because I just accidentally froze my screen. So, but what we're going to do now is we're going to run these benchmarks concurrently, and we're going to run that with multiple sessions. So if I do time, first of all, I can time the command, but I've got a script here in the scripts directory called run concurrently, and it's going to run 25 concurrent sessions, each running the 22 query benchmark. So we're going to try to beat the crap out of our phone here and just like pound it with a lot of activity. So you're going to have 25 sessions all running the TPC-H benchmarks, all 22 queries each. So we're going to actually run, hundreds of queries in just a few seconds, hopefully, on this device. So let's go ahead and hit enter, and we should see that session count right here bump up big time. And boom, it's up to 26 now. And all those 25 sessions are just pounding the phone, pounding the database server, and running those TPC-H benchmarks. And you can see the session count start to drop, some of them completing, and boom, we're all done. So that concurrent script outputs the benchmark stats for each of the 25 sessions. And there's another thing, another script in the script directory, a Python script called Gantt.py, that will generate a Gantt chart that shows the session concurrency stats when they started, when they finished for each query. So let's go ahead and run that. And that output this thing over here. It opens up in your browser, and you can actually see a Gantt chart of all the queries that run. And so if I zoom in here, you can see those sessions for TPC-H01 query and the PID, the process ID, 1 through 25, let's say, 1 through 24, or 0 through 24 rather, and see when the query started and when it finished. So you can see this one query took a little over 1 second on PID 15, for example. So if we scale back out, or zoom back out rather, and you zoom in here, you can see that different sessions run different queries sometimes at different times. So these sessions at this time were running TPC-H09, but another session was running TPC-H07. So you kind of get some different performance characteristics based on which session started the query first, things like that. But overall, you do see a large amount. If I draw a line here, you do see a large amount of concurrency that is happening on the device. So even an iPhone with GizmoSQL running is an enterprise database server. You're going to get that excellent performance and amazing concurrency, everything like that. All right, so if you want to get an idea of the logs when we run this guy, I'll just do it again here, and you're going to see the logs go nuts. So do the 25, and boom. I mean, the logs are moving so fast, you can't even kind of gauge what's going on. And so all 25 of these sessions running 22 queries each, you get an idea of the workload we're actually running on this phone. And that all finishes in about 15.4 seconds. So you're not going to get the same performance as if you just run one session. So there's a little bit of a concurrency performance penalty, but that's normal in any database system. The system, after all, only has 6 cores, and we threw a lot of activity at it from 25 concurrent sessions. If you kind of want to get an idea of when this thing breaks, you are limited by memory and CPU, of course. So if we go to 50, I have an idea that this will actually crash the app. It is an iPhone, right? So we can only throw so much at it. So we'll go ahead and kick off 50 sessions and see what happens. And you can see the app did indeed crash. So there is a limit to what you can do. If you want to run 50 concurrent sessions, you probably need to own a bigger server, like run on your Mac or run on a Linux box or Windows with some more resources than, of course, than an iPhone would have. So I just want to demonstrate that you can actually run some serious processing with GizmoSQL, powered by DuckDB and Apache Aeroflight SQL. It is secure, it's performant, it's enterprise grade, and the enterprise edition that we have, which is in addition to the core version, which is free and open source, we have the enterprise edition. Got some extra security goodies like single sign-on, instrumentation that records all the sessions, all their activity. You can see every query, every performance characteristics. You can actually kill other sessions, and you have per catalog token authentication. So you can have, catalog A, user has read-write. On catalog B, they only have read-only. In catalog C, they have no privileges. So you can actually set those up, those per catalog permissions, in a login token. And so you get an extra layer of security with the Enterprise Edition. So if you're interested in the Enterprise Edition, contact us at gizmodata.com. We'd be glad to give you a demo of the enterprise features and talk with you more. So thanks very much for looking at this video. I appreciate it, and I hope you have a good day.